Graphs that represent situations. In this video, you'll learn how a quadratic equation and its graph relate to a situation. So the standard form of a quadratic is ax squared plus bx plus c. And this is the best form when we want to find y-intercepts. The factored form of a quadratic is a times x plus m times x plus n. And this is the best form when we want to find x-intercepts. So let's look at some examples of both types. The equation h equals 2 plus 23.7t minus 4.9t squared represents the height of a pumpkin that is catapulted up in the air as a function of time t in seconds. The height is measured in meters above the ground, and the pumpkin is shot upward at a vertical velocity of 23.7 meters per second. So let's take the equation they gave us and analyze each piece. We know that the equation represents the height of a pumpkin, so h will tell us the pumpkin's height. And we know that this is a function of time t, so the variable t will represent the time. And we know that it's shot upward at a vertical velocity of 23.7 meters per second. So the 23.7 represents our velocity. The number 2 is our constant, so this tells us our y-intercept, or the pumpkin's initial height. And the negative 4.9 represents the gravity that will pull it down. Since this is our a value and it's negative, this tells us that the parabola will be upside down if we were to graph it. Now let's look at another one. The equation y equals negative 16t minus 2 times t minus 1 represents the height in feet of a beach ball thrown by a child as a function of time in seconds after the ball is thrown. Let's start by finding the zeros of this function. So we'll take the equation, and we know that y is going to be equal to 0 since we're finding the x-intercepts. So we'll set each parenthesis equal to 0 so we can solve for t. We'll start by adding 2 to both sides, which gives us negative 16t is equal to 2. And then we'll divide both sides by negative 16, which gives us the value of t of negative 1/8. In our next equation, we'll start by adding 1 to both sides, which gives us a value of t equals 1. So now we know that the zeros are at negative 1/8 and 1. So this tells us that the ball hit the ground at negative 1/8 second and at 1 second. Since we can't have a negative value for time, the negative 1/8 won't really work in our situation, but we do know that after 1 second, the ball hit the ground. Now let's determine from what height is the ball thrown. So we're looking for the initial height. So we're going to take our equation, and since the time will be 0, we'll replace t with 0 and then solve for y. Multiplying negative 16 times 0 will just give us 0. So we have 0 minus 2 times 0 minus 1. This will give us negative 2 times negative 1, or positive 2. So now we know that the ball was 2 feet when it was thrown. In this example, 2 objects are launched into the air at the same time. Functions f and g represent the heights of the objects above the ground as a function of time t seconds after being launched. So we can see that our x-axis represents the time and the y-axis represents the height. Which object was launched from a higher point? So this will be determined by looking at our y-intercepts, since this tells us where the object was launched. We can see that graph G has a higher y-intercept, so G was launched at a higher point. Now to determine which object reached a higher point. So this time we're going to look at the vertex of each parabola. And we can see that function f reached a higher vertex than function g. So function f reached a higher point. Let's look at one more example. The height in feet of a thrown football is modeled by the equation f of t is equal to 6 plus 30t minus 16t squared, where time t is measured in seconds. What does 6, the constant, represent in this situation? This tells us that the football was thrown from a height of 6 feet, since this represents the y-intercept. And what does 30t represent in this situation? This is going to represent the initial upward velocity of 30 feet per second, since that's how the ball goes up. The negative 16t squared represents the gravity that will pull it back down. Now let's summarize what we've learned. We can use quadratic functions and their graphs to represent objects in motion. Key features of the graphs, like intercepts or the vertex, can be interpreted in context to describe height, time, and maximum points.